Melon, and remember, the universe today has 350 billion galaxies, each with 100 billion stars. Once upon a time, it was the size of a melon. Kaku is one of the most prominent voices in the world of theoretical physics. Known for his ability to bridge the gap between the complex and the accessible, Kaku has spent decades exploring the mysteries of the universe. However, his latest revelations about quantum physics have sparked a mixture of awe and concern. Quantum physics, the science of the very small, is not just an academic curiosity. It's a reality-shaping force that could have profound implications for humanity's future. What Kaku has revealed isn't just about the promise of quantum mechanics. It's also about the dangers that come with it. To understand why Kaku's latest statements are so alarming, we first need to delve into what quantum physics is. At its core, quantum physics is the study of the smallest building blocks of the universe. It's about particles like electrons, photons, and quarks, entities so small that they defy our conventional understanding of reality. These particles operate in ways that are counterintuitive, unpredictable, and downright bizarre. They can exist in multiple places at once, teleport across space, and even influence one another instantaneously over vast distances. This is where the concept of quantum entanglement comes into play. When two particles become entangled, their states become linked no matter how far apart they are. If you change the state of one particle, the other reacts instantly, even if it's on the other side of the universe. Albert Einstein famously referred to this phenomenon as spooky action at a distance, and it's one of the key principles underpinning the quantum revolution. While entanglement might sound like a strange quirk of the quantum world, it has very real implications for technology and society. Quantum entanglement is the foundation of quantum computing, a field that has the potential to revolutionize everything from medicine to artificial intelligence. Yet, as Kaku warns, the very same principles that could usher in a new era of progress also come with risks that we are only beginning to understand. Take quantum computing, for example. Unlike classical computers, which use bits to process information in binary form, quantum computers use quantum bits or qubits. These qubits can exist in multiple states simultaneously thanks to a phenomenon known as superposition. This allows quantum computers to perform calculations at speeds that are incomprehensible by today's standards. In theory, a quantum computer could solve problems in seconds that would take classical computers millions of years. The promise of quantum computing is enormous. It could unlock new cures for diseases, optimize global supply chains, and revolutionize artificial intelligence. But Kaku points out that this power comes with a dark side. Quantum computers could also be used to break modern encryption systems, effectively rendering all current cybersecurity measures obsolete. Imagine a world where every bank account, government database, and private communication is vulnerable to being hacked. That's the kind of future quantum computing could create if it falls into the wrong hands. Kaku has described this as a potential quantum arms race. Governments and corporations around the world are investing billions of dollars into quantum research, vying for supremacy in this new technological frontier. The stakes couldn't be higher. Whoever wins this race will gain unparalleled power, not just in terms of computational capabilities but also in terms of geopolitical influence. What happens when this technology becomes so advanced that it spirals out of control? Kaku warns that we may be on the brink of creating machines that even we don't fully understand, let alone control. Another troubling aspect of the quantum world is its potential to challenge our understanding of reality itself. Kaku has spoken extensively about the philosophical implications of quantum mechanics, particularly the concept of the multiverse. Quantum physics suggests that our universe is just one of many, a single bubble in a vast multiverse where countless other universes exist, each with its own set of physical laws. This idea isn't just speculative. It's supported by experiments that demonstrate the probabilistic nature of quantum mechanics. When a particle is observed, it collapses into a single state, but prior to observation, it exists in a superposition of all possible states. Some physicists interpret this as evidence that every possible outcome of a quantum event actually occurs, each in its own separate universe. If this is true, it raises profound questions about free will, consciousness, and the nature of existence. Are we just one of an infinite number of versions of ourselves, each living out different possibilities in parallel universes? And if so, what does that mean for our sense of identity and purpose? Kaku argues that these questions aren't just theoretical. They have real implications for how we view ourselves and our place in the cosmos. The most alarming aspect of Kaku's revelations is the idea that we may be tampering with forces we don't fully understand. Quantum mechanics operates on principles that are fundamentally different from the macroscopic laws of physics we experience in everyday life. While our understanding of the quantum world has grown exponentially, there's still so much we don't know. For example, scientists have recently begun exploring the possibility of creating artificial black holes in the laboratory. These are not the gargantuan black holes found in space but microscopic versions created by manipulating quantum fields. While this research is groundbreaking, it also raises serious ethical and existential questions. Could we accidentally create a black hole that grows out of control, swallowing everything in its vicinity? While most physicists dismiss this as unlikely, the mere possibility is enough to give pause. Then there's the question of quantum artificial intelligence. As quantum computers become more powerful, they could revolutionize AI, allowing machines to process information and learn at unprecedented speeds. This could lead to incredible advancements in medicine, engineering, and countless other fields. But it could also lead to the creation of AI systems that surpass human intelligence, a scenario that has been described as both an opportunity and an existential potential threat. Kaku has spoken about the dangers of runaway AI, where machines become so advanced that they begin to act in ways that are unpredictable and uncontrollable. In a quantum-powered future, this risk becomes even more pronounced. If we create AI systems that operate on quantum principles, their behavior could be governed by the same probabilistic rules that define the quantum world. This would make them inherently unpredictable and potentially dangerous. It's not just AI that poses a risk. Quantum technologies could also have unintended consequences for the environment. Quantum experiments often require extremely low temperatures, achieved using cryogenic systems that consume vast amounts of energy. As the demand for quantum computing grows, so too will its environmental footprint. Kaku warns that we need to consider these impacts carefully, lest we create technologies that exacerbate the very problems they're meant to solve. Perhaps the most unsettling possibility is that quantum mechanics could one day reveal that our universe is not as real as we think. Some interpretations of quantum physics suggest that reality itself is a kind of simulation, governed by underlying mathematical rules. If this is true, it raises questions about who or what created these rules, and why. Are we living in a simulated universe designed by an advanced intelligence? If so, what happens if we start to tamper with the code? Kaku has described this as the God question, the idea that quantum physics could one day lead us to discover the ultimate nature of reality. While this prospect is inspiring, it's also deeply unsettling. If we're living in a simulation, what happens if we break the rules? Could our attempts to manipulate quantum systems have unintended consequences that destabilize the very fabric of our reality? These are not questions with easy answers, and they underscore the need for caution as we explore the quantum frontier. Kaku emphasizes that we're entering uncharted territory, and the stakes couldn't be higher. Quantum physics has the potential to unlock the secrets of the universe, but it also comes with risks that we're only beginning to understand. So what can we do to navigate this brave new world? Kaku argues that the key lies in balancing exploration with responsibility. We need to invest in quantum research, but we also need to establish ethical guidelines and safeguards to prevent misuse. This will require cooperation on a global scale, bringing together scientists, policymakers, and ethicists to ensure that quantum technologies are developed for the benefit of humanity. In the end, Kaku's message is both a warning and a call to action. Quantum physics is a double-edged sword, capable of unlocking incredible potential but also fraught with risks. The decisions we make today will shape the trajectory of human civilization for generations to come. Will we rise to the challenge, or will we become the architects of our own undoing? The choice is ours and the clock is ticking.